Today we are going to see about the engineering materials, or we can say it as building materials that is involved in the construction. So building materials here, as per normal people, we have to understand a few of the basic building materials. They are the bricks, stones, cement, steel, wood and concrete. So civil engineering, though we say that it has construction as a major unit, we have to involve these materials, basic materials, for construction of the buildings. So here the bricks, as we know, it is made up of burnt clay or burnt mud, and we have the natural stones. Then we have the cement that acts as the binder, and we have the steel in the form of reinforcement steel or as a structural steel, we have them. And we have wood that is processed and then being used as structural elements to make it as a rafter and column units, or as frames to door units or furnishings. And we have the concrete, the ultimate that is formed as an artificial poured into a mold and formed into different structural members. We can see that why these materials, and when we are using these materials, what and all it has to satisfy. So we have 5 aspects with respect to it, that is strength and stability. Second one is your durability, then your economy, then your workability, then aesthetics and sustainability. So first and foremost, it is the strength and stability. As we know that in construction of buildings inside that, people have to occupy inside that, and we have to use that building for certain form of functions. Say we are accommodating inside, it can be a living room, it can be a bedroom, or it is a public building where it can be used as a classroom, or it is a institutional building, or it can be a hospital building, or whether it is a building, or we can come up with say bridges where the traffic has to be having its movement, or say it is a dam structure that has to retain the liquid materials or water, or it can be your highways where you have to you're forming the road, and it can be extensive multiple purpose buildings or highways or dams or many other infrastructures. These 5 things should be there. So strength and stability, it has to be strong enough to withstand the loads, to resist the stresses caused by the external forces, and it has to have that stability, it has to be stable. And then the durability, when the stability is the sense that where the structures will be having its form without any much deformation or without overturning or toppling or such cases. And second, the durability, the extension of that period, for how much days or how much period it can be durable, for how much years it can be durable. Third one is the economy. So when we say economy, the building materials, we can't be using too much costly items when you can go for some other alternative. So it also involves the cost. It is usually the costliest one because it has to be processed, the materials has to be processed, it has to be formed into a particular mold. It can be or whether if it is a cement, then it has to be processed and made into cement, then further it has to be mixed and made into mortar and concrete. Or it can be your sand is also sand or sand, it has to be processed. Sand that is available as a natural resource, still if it is being depleted, we have to check on it. And whether it is steel, so steel, the manufacture of steel itself involves so many processes, so it is all relevant to the economy. So the material, the choice of material that we pick for the construction, it should be economical. Then we have the workability means the ease of using those materials in making the structure or making the building or making the infra. Okay. Then the aesthetics and sustainability. So when we speak about the aesthetics, not only as a structural performance, and also the appealing should be good with respect to the buildings and the structures. And sustainability is that it is friendly towards the environmental, so we cannot impact the environment to a greater extent. It should be having some cap, so we use the resources much without exploiting, and we must be able to have that one a balance between the usage and conservation and everything. So that is about your sustainability. So next we have we can go into the first part, the basic one, that is the bricks. So bricks, we can know that it is a rectangular block that is made from the mud. So when we say it is a rectangular block made from a mud, how it is being made? It should have certain composition. So these are the 6 composition that you can see, major compositions that are present in this mud. So whether we can take mud and directly make it as a brick? No. That brick, that mud has to be first separated from all the debris and other things, and we have to check whether it has this composition, this limited composition is present in that mud, so that it can be further be molded. It has to be mixed with the water and other ingredients, and it has to be molded. Then after being molded, then it has to cured in dry in air, and then it has to be burnt. So how it is burning inside a furnace, whether the mold is stable enough to burn inside the furnace and come out as a proper brick or not, we have to check these things. So we can see here different bricks are there, we can see in the upcoming, but this is one of the first form where the man has made a block for him to build. So in that case, this is the first one, this is the first man-made thing to make it as a block and then to build. We can evolve like that. Rest, you can see the percentage of alumina, silica, lime, iron oxide, magnesia and organic matter that are present. So when we say these materials are present in the bricks, what happens then? So the alumina content present in so much in the mud can provide plasticity and molding. So we can know the plasticity, it is that ability to form into a mold ability, and it should be having certain extent of elasticity also, and ease in molding. You can know that how we prepare a dough, similar to that the mud also and the clay also is prepared like a dough, and then we will have to mold it. So alumina helps in that. Then second one is the sand component present. So you can see that the major clay component, that is the alumina component, will help in plasticity and molding. And second one, you can see that silica component, this is the majority major composition in the brick manufacturing. So in the brick we can say that the mud that should have that content. So silica is around 50 to 60%. This actually provides the skeleton or the hardness to the brick to be formed. Okay. Then the third one is the lime content. So this lime present in the mud helps in sticking, means the binding or the adhesion, that provides that. And next is the iron oxide. This gives the strength, as the iron it gives the strength, and also the red color of that brick usually is dominated because of the presence of the iron oxide. The color of the mud itself will actually come as an end product when we make it as a brick. Then magnesia, and this one you can see the function of it, it reduces the shrinkage and imparts the yellowish tint. Shrinkage means when we mix the mud with the water and then when we prepare it into a mold. Now after allowing it to dry, what happens to the water? It gets evaporated. So when it gets evaporated, there is a tendency of this to leave the cracks, because the volume of the mold and the volume of the material in that mold initially will be filling that volume. So once the water gets evaporated, this volume will reduce. When it is reducing, the cracks also will appear in that. The shrinkage happens because of the loss of that water that prepared that clay into a particular mold. So that one is also there. So we can say that magnesia will not allow too much of shrinkage to be happening to the brick mold.